Now that you've seen how graphs can shift up and down and how other graphs can shift left and right, let's put all of the ideas together in the bottom half of page 24 here. The equation in number 7 is going to feature both a horizontal and a vertical shift. So if you think you have some predictions about how this is going to go, take a quick moment and consider maybe pausing the video to predict as many things as you can in this first space in letter A. While you're making your predictions, just think about what you've seen so far. Think about what x minus usually does. Think about what the plus 1 usually does, and see if you can articulate some of those things in this blank space. Again, you can pause the video so that you have some time to think about these things and to make some observations. And once you're ready to do that, we're going to fill in this little table of values, sketch the graph, and see if your observations are true. Another thing that might be helpful once you're ready to kind of think about your predictions is to consider formalizing some of your ideas. This might be a good time, if you're a formula person, to consider some notes for yourself. And I'll give you a little bit of a structure to kind of help you out. The general principle that we're dealing with here is really based on where the numbers are in the equation and the role of each of those numbers based on its location. So I'm going to kind of break down 3 important numbers in every sign equation so that you can make sure that you have a sense of what each one of them does and why each one is important. The first number in an equation that we usually notice is that number right there in the front. That number in the front we used to call the a value back when we were dealing with parabolas, and you can still use that a value terminology here as well. But the a value really does 2 jobs. First, it tells you which direction the graph goes in. So for example, if I'm looking at the graph in number 7, I don't have an a value visible, so I'm going to assume there's just a 1 there. And that's telling me, since it's a positive number, my graph is going to go up from the starting point. That no matter what dot I'm starting at, the graph is going to go up from there, kind of like this one that you see that we did previously. The other thing that it tells us is the height or the distance we go up from our starting point. So if the a value is 1, that means that the graph is going to go up 1 full unit to get to the top of that hill. Or if it goes the opposite way, goes down 1 full unit to get to the bottom of the hill. So that height could refer to an up or a down, but generally speaking, that height is just the distance from the starting point to the next dot. Now the numbers inside and after the parentheses are the ones that control the shifting. We know that the inside parentheses controls the horizontal shift to the left and to the right, and the number outside the parentheses controls the vertical shift, up or down. In order to put that in more familiar terms, in case those are things that you want to remember, we usually use the notation x minus h to talk about the horizontal shifting, and plus k to talk about the vertical shifting. That, of course, could differ in theory based on whether you're going left versus right or up versus down. For instance, if you're going to the right, x minus h is what you'll see, because it's always the opposite. Right is a positive direction, and the equation will always say x minus. And left is the opposite, x plus h, because it always does the opposite of what you'd think. The k value is the one that stays true to itself. Up is a positive k and down is a negative k. So those are things worth making a note about. Perhaps more importantly, many of us always think of those coordinates, like h and k, as a single point, and you could definitely think about that if it helps. We usually call this point the reference point. Some people call it the starting point, because that's usually the point that we end up making on our graph first. That's the one that you can think of when it comes to actually making sure that you have a dot, that yellow dot on the graph where everything begins from. So if you want to kind of summarize this idea, all of the left and right and up and down stuff just boils down to one set of coordinates, h and k. So with that said, let's see if we can think about the predictions that you might have made and see if some of those predictions ended up coming true. I'm actually going to do letter B a little bit backwards. I'm going to do the graph first based on some predictions we can make from our equation and these ideas, and then I'll do the table to confirm whether our predictions were actually valid. The first thing that I'd like to do, of course, is to make sure that we make that yellow dot. And that yellow dot, again, comes from the starting point, HK. So again, I'll color code this just so you can see it here. The yellow dot is the one that comes from the H and the K in the equation. I'm looking at my equation and I'm seeing x minus pi, which is tipping me off that that's probably going to be a positive because x minus always does the opposite of what you'd think. And then the plus 1 is telling me positive 1 to be my y coordinate. So if I want to think of it like coordinates, I'm going to think of the coordinates of my starting point as pi, comma, 1, which tells me that I can go to my graph, I can go to the right pi, that's positive pi, and then up 1, and I'll have a dot right there. Now, the a value is going to come in handy. Once I used all of this information about the h and the k, I can use the a value. This a value, again invisibly, is a 1, which tells me two things. First, that's a positive number, so it's telling me from my starting, or my yellow dot, I'm going to go up 1. So I'll make my dot yellow there just so you can see it. I'm going to go up to make sure that it's positive. And the height number is 1, which tells me from that dot I'm going up 1 unit to make my next tick mark. Now I'm not really paying attention to the actual coordinates of the x-axis here. I'm just paying attention to the y-coordinates. So from my starting dot, I'm just moving to the next tick mark and going up 1. Then the pattern hopefully kicks in. We go up 1, then we go back to where we started, then we go down 1, and back to where we started, and we let the pattern continue to repeat itself. So up 1, back to where we started, down 1, back to where we started. You can even go backwards. We were here in the middle, so down 1, back to where we started, up 1, back to where we started, and then we can connect the dots so we can see it all clearly. Now, of course, you can connect as many or as few of these cycles as you want to just so you can see it, but this hopefully now is a correct graph. If you're looking at this wondering if we're correct, you could fill in the table and actually make sure that the points work. I'm going to do this part just for mathematical thoroughness, but if you don't necessarily feel like you quite understand where I'm getting these numbers from, don't worry. I'm basically just going to do a lot of mental math really quickly for the sake of time. If you get confused about where I'm getting any of these numbers from, don't panic. Most of this is not essential information. I'm just showing it to you for reference so we can prove that our instincts about our graph were correct. So I'm just going to do a little bit of scratch work really quickly. I'm going to convert all of my pi's back into radian numbers, or sorry, all of my pi's back into degree numbers again. And I'm going to rewrite my equation as x minus 180 plus 1. Again, this is not a mandatory step. This is me just showing where all the numbers come from so you can validate that your work is actually correct. If you want to fast forward through this part, this is not essential, so don't worry about this. If I do want to do these numbers, though, I have to check. So sine of 0 minus 180, that's negative 180 plus 1. I can't do negative 180, I have to do a coterminal angle, so I'll do add 360. That gives me sine of positive 180 plus 1. That I can do, because sine of 180 is 0, 0 plus 1 is 1. Now I'll do the same thing for the next one. The next one is going to be sine of 90 minus 180 plus 1. That again is going to give me a coterminal situation because I have negative 90. And if I do my add 360 technique, I'll get sine of 270 plus 1. Sine 270 is negative 1 plus 1 is 0. Now I'll do the same thing for 180. That's sine of 180 minus 180 plus 1. This one, fortunately, is less work because 180 minus 180 is 0. Sine of 0 is 0 plus 1 is 1. The next one is going to be pi over 270. So sine of 270 minus 180 plus 1. That's sine of 90 plus 1, which is 1 plus 1, which is 2. And then the last one is 360. Sine of 360 minus 180 plus 1 is sine 180 plus 1, which is 0 plus 1, or 1. Now, the whole reason for that exercise was to just show these are the exact points on the graph that we already thought were there. 0, 1 is right there. 90, 0, or pi over 2, 0 is right there. Pi 1, boom. 3 pi over 2, 2, boom. And 2 pi 1, boom. So we were totally correct with our instincts, which validates the idea that our instincts about graphs, the things we already know from previous units about how graphs work, is definitely going to override the need to do all of that mathematical calculation in the table. And going forward, you're not even going to need to use the table. You can just use your instincts about how h and k work, as well as the information about the direction, the a value, and the height, so that you can just make a prediction about how a graph looks without having to do all this extra work. So in the last set of questions here, see if you can ignore this whole table business altogether and just use your best instincts about these graphs to not have to reinvent the whole wheel. So I'll do question letter A with you, and then I'll ask you to finish the rest of them using your instincts. Let's see if we can make this happen efficiently. In letter A, the first place that I usually want to go is the yellow dot, and that's going to be my h and k. Since this says x minus pi over 2, that implies the x coordinate of my starting point will be positive pi over 2. Again, always the opposite of what we expect. The y coordinate tells me negative 0.5. Not what I'm supposed to take as is. So that tells me that my starting dot is going to be at positive pi over 2, so that's right pi over 2, and down 0.5. Since it looks like these units are counting like 0.5 and then 1 and then 1.5, I can assume that's down one little tick mark, so right around there. So there's my yellow dot, there's my starting point. Now that I have my yellow starting point, I can do the rest of the points using the a value as the kickstarter there. So the a value again is going to be 1 because they didn't give us a number otherwise, and that means from my yellow dot I'm going to go up 1 full unit. Now just remember carefully on these graphs, 1 full unit is like 1, 2 ticks. So when I go up 1 full unit, I need to count to make sure that I've gone the full distance. 1 unit is like 2 little tick marks up. So I went 1 unit up, and then of course the pattern, so back to the center again, and then 1 unit down, and back to the center again. And you can continue the pattern as far as you want. Up and back to the center, down and back to the center. And you can go backwards as well, down and then back to the center and up if you want to keep the pattern going a little bit further. Once you've gotten the pattern though, you should hopefully be able to see it take shape pretty easily. And that is our graph. Now that you've seen a few examples and hopefully had some time to put together the idea, try letter B just to see if you can kind of piece it together, and then try question number 9. Because question number 9 is giving you a graph already done for you and asking you to write the equation. So you can kind of piggyback off of some of these ideas to write an equation using some of these patterns and structures. So in the time that you have, hopefully you can finish letters B and 9, check the answer key using the key provided on the plan, and make some sense of the ideas. The next assignment after you finish this one is going to be hopefully for a separate day, but you'll be finishing pages 25 and 26 in the packet, and those won't have videos. Those are just practice of what you're seeing here. I would recommend, if you need help on pages 25 and 26, looking at the answer key or rewatching some of these videos to see if some of the ideas make sense in a second or a third run through. If you have any questions while you work, you're always welcome to send an email and be as specific as you can about what you need. Good luck.